In this video, we'll learn different types of factors and useful method for finding the factors of the number. Factorization is a process by which a whole number that is not a prime number is broken down into its factors. So you might be asking questions about some people would know what is a prime number that has only two factors, one and itself. Means it is divisible either to the one or either to itself. It's not divisible to anything else. This is prime number. What's the opposite of prime number? Prime numbers are the one with two factors. Can anyone guess what's the opposite of the prime numbers? There are actually composite numbers. Now, composite numbers have more than two factors. I'll give you examples for the both to clarify. 2 is the only even prime number. We have 3, we have 7, we have 11. All these are the prime numbers which have only two factors. Now, for the composite numbers, you can say 9, you can say 22, you can say 60, so on. 2 is the only even prime number. All other prime numbers are odd. So, this is the process of expressing a number as a product of its prime factors. This whole process is prime factorization. I think we would better understand it with the example. I would be going on with two examples. Number one is 315, and we'll take another example as well. So, how to know which number to divide to? For this, you can go for the two ways. Either you use the tests of divisibility. There are some tests of the divisibility as I started this series with that video, so you had a better idea about it. You can go on and check that video so you know what are the tests of divisibilities, and you can find out by looking at the number, or you can guess. How to guess? For guessing, you start out with the 2 and you go your way. You have to find out an integer value. This is a floating number. You have to find an integer answer. You go up to the number where you find out, well, see, it's divisible to 3. And what answer it gives? 105. You can go on, mostly you have to go on up to like 15 sometimes in rare cases to find out which number it is divisible to or not. But you can use the test of the divisibility as it's 105. So my common instinct would be it is divisible to 5 as it ends with a 5. And see, it's right. Now for the 21, I know that 21 is divisible in 3. It is divisible to 7. As whenever there's a prime number, we end it by multiplying. 7 is a factor of 1 in its own table. We end it. So how do we write it? We write it by 3. Let's change color to make it more attractive. We write it by 3, 5, 3, and then there is a 7. 3 appears 2 times. We can write it as 3 square multiply 5 multiply 7. So these are the prime factors. Let's take another example. So, just to get a better idea of the topic. Let's take a bigger number like 2, 3, 0, 4. Now, if I have known the test of divisibility, I know that 2304 ends with a even number, which means it is divisible to 2. So I would not waste my time in making guesses. I would rather just divide it directly to the 2. It gives me an answer of 1152. Now again, I know it is ending with an even number, which means it is divisible by 2. See, it gives the answer of 576. Again, 576 ends with a even number, which means it is divisible to 2. Go with the smaller numbers. Don't just directly jump on to the larger numbers. Start with a 2, 3, and up to so on. Again, 288 is divisible to 2. These rules of the divisibility comes handy in a lot of situations. 72. Now 72 again being a even number, just divided by 2 again. 36. We know 36 comes in the table of 2 at 18. 18 comes at 9. 9 doesn't come in the table of 2, but it does come in 3 at 3. Now 3 is a prime number, so I would end it with a 1. Now these are the all factors. Let me write the factors. 1, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 times 2. And then there is 3 2 times. So this is the prime factorization.